welcome back. I'm Miss Lisa, and this is my YouTube channel where we talk about all things math and science. Today we're talking about chemistry, and in particular, equations. So what is a chemical reaction? Well, normally I strike a match, and I go, this is a chemical reaction, but you've all seen a match, so imagine that I did it. I forgot to get my matches. So imagine the match is burning. Think about this match. Once I strike it and it burns and it's all black, can I get it back to a match again that's not been struck? Nope. It has become something new. It was wood and some chemicals on the end, but now it is something new. It's carbon, it gives off smoke, it gave off light, it even gives off a sound. You can see that. So there's a lot of evidence of chemical reaction, a color change, light, heat, sound, smoke. All of those are evidences of chemical reaction. So if we just had some water and we boiled it and made it steam, it would not be a chemical reaction, because even though it made something that looked like smoke, it made a gas, but the composition of that gas is still H2O. It's water vapor. And the liquid water is H2O. It's liquid water. If we froze it, it would still be H2O, just frozen ice. So for it to be a chemical equation, for it to be a chemical reaction, it has to change into something new. It has to have bonds broken and bonds formed, and it's going to have a new formula. Now, one way I like to teach writing equations is this recipe. And I don't know if y'all can see it because there's sort of a glare on my board. I think you can. It says 1 PBC. What that means is 1 cup peanut butter plus 1 cup sugar plus 1 egg plus 1 teaspoon of vanilla makes, the arrow is like yields or makes, 1 batch of peanut butter cookies. Now, this is a famous recipe, and it's very popular right now. My neighbor invented it a long time ago. She won the Pillsbury Bake Off, a new kitchen, and I think $100,000. But this was one of the recipes she made. I think she didn't win with this one, but I think she placed with it a different year. The one she won with was some onion cookies that you would eat with soup or something. But anyway, she was creative in the kitchen. Well, this is not how you normally write an equation, is it? Normally, I would list the ingredients down and then I'd write a little paragraph. Well, this is how you write recipes in equation form in chemistry. Equations are just recipes that I can use as a chemist to go make what I need. Monday, I'm going to be having my students at school doing a lab, and I got to get there early because I got to make some stuff to have the chemicals all ready for them to go. So the equation tells me the amounts, it tells me what I need to combine, and it tells me what I'm going to get. Now, the amounts in my recipe are these numbers in front. And it's not really like a real equation, because in a real equation, you're consistent with units. But with this, I have cups, and then I have eggs, and then I have teaspoons. But it really works. If you want to make these cookies, the reason why they're so popular now is they don't have flour. They use the nature of the proteins in the peanut butter to make them rise and have that strength. So they're gluten-free. Everybody's into gluten-free, and they're making Mabel's cookies. So sometimes on the arrow, on what it makes, conditions are written for the reaction. And the conditions for this reaction is 325 degrees Fahrenheit for, I'm going to say 8 to 15 minutes. I usually say 12 to 15. But I think I don't want you to burn your cookies if you decide to make it. I have my kids I teach at school, they can do this or make a different recipe and write it like an equation to make up a lab, because cooking is chemistry. Could we get the peanut butter, the sugar, the eggs, and the vanilla back again after we make our cookies? No. If you decide to make these cookies, don't put semi-sweet chocolate chips in them. It's not a sweet enough recipe to handle it. Milk chocolate's fine. Peanut butter chips are fine. Butterscotch chips are fine. But semi-sweet, meh. All right. So This is another recipe written as a reaction. Here I have hydrogen gas plus oxygen gas makes water, which I think I need some right now. I'm kind of choking. So this is a recipe for water. What you put in are called the reactants. What you get out are called the products. So, and notice that they're very different. That it's not a mixture. In a mixture, what you make retains the properties of what you put in. So, like my favorite mixture is Nestle's Quick. No, I don't get any sponsorship from them, but I'm here, Nestle, if you want to sponsor my channel here. When I make Nestle's Quick, I put 4 heaping tablespoons of Quick in a glass of milk. My husband thinks it's disgusting. He says, no, you get 1 spoonful, you scrape it off. But when you drink chocolate milk, you can taste the chocolate, you can taste the milk, you can taste the sugar. It retains the properties of what was put in it. Bonds are not broken and reformed. When you do a chemical reaction, bonds are broken and reformed, and it no longer retains the properties of what was put in it. Hydrogen gas is explosive. It's a gas. Oxygen gas is flammable. It's a gas. Water is sort of the opposite of those two things. It puts out explosions and fires, and it's a liquid. Liquid water is what we would make at room temperature. We're assuming we're doing this at room temperature. So what you put in are called the reactants. What you get out are the products. The numbers in front tell you how much you have. You can also have other symbols in the equation to tell you more things. Sometimes the state of matter is there. It'll be written in little, in parentheses, like it would be solid peanut butter. Well, sugar is a crystal, so sometimes you have CR for crystal. Eggs, we'll call that a liquid. We'll give it an L. Vanilla, that's a liquid. So those little L's and S's, so S stands for solid, L for liquid, G for gas. You can also have an arrow up that can mean gas. And solid can also be an arrow down. AQ means aqueous, dissolved in water. CR, crystal, like our sugar. Arrow down the arrow down is found in the products, and it means it precipitates out. It means that a solid formed in the liquid. A precipitate, you hear that on the news, you hear it on the weather, and it means rain or sleet or snow. It's one phase of matter forming in another one. So our atmosphere is all gas, and if we have rain form in it, a liquid is precipitation or snow or sleet. What we do in chemistry class for high school is usually we pour liquids together. And if a solid forms in it, that is a solid precipitate. The abbreviation is PPT, precipitate, or an arrow down. It means usually it's like a powder settles in it. It gets cloudy and then the powder settles, like my Nestle's Quick. So then also it can make bubbles when you pour it together. In my class last week, we put Alka-Seltzer in water and watched it bubble as evidence of a chemical reaction. And so that would be an arrow up. Sometimes there's something written on the arrow that you add that's a chemical, like PT or PD, palladium, platinum. Sometimes you will put a chemical in the reaction that doesn't actually take place in the reaction, but it helps it go. It's called a catalyst. And in our body, you probably had biology last year, and in biology you learned about in our body we have enzymes as catalysts, and they will get one chemical and another chemical and put them together. They're like a matchmaker that helps them get together and do their chemical reaction. Sometimes you have heat in the reaction, and that's what I have here. Sometimes it is a temperature written usually in Celsius degrees. We don't do Fahrenheit in the chemistry lab. And sometimes there's a time. Sometimes there's a triangle or a triangle H, which just means you need to heat it up. The triangle is the Greek letter delta, and it means change or difference. And it means we need a difference in heat, which means fancy science for you got to heat it up. Sometimes I'll have the little word heat to mean you got to heat it up. It can have a temperature on it. Another thing it can have is like kPa, That stands for kilopascals. And like, what are you doing to Pascal? No, we are not killing Pascal. It's pressure. Sometimes you have to put it under pressure. Sometimes there's a little E with a line. That means you got to zap it with electricity. So like Frankenstein. Oh, all right. So that's how you write equations. Then sometimes equations are called reversible, or they will come to equilibrium. What that means is instead of one arrow showing what you get, sometimes the arrow will go back and forth. I don't know if you can see it there, but that's what that is, a back and forth arrow. What that means is when I dump my two beakers of liquid together, that in the end I will have some of the products, but some of the reactants won't all react. I'll end up with everything in the beaker at the end. It doesn't go to completion. My peanut butter cookies go to completion. I can't get them back out. I don't end up with the little peanut butter, sugar, egg, or vanilla in the end. All of it ends up being part of the reaction of the peanut butter cookies. All right, so I want to teach you about 5 types of reactions in this video. And we're going to have another video that is going to be a follow-up one called Writing Net Ionic Equations. But it's really a more honors level concept. I usually don't make my regular chem do it. So it's going to be optional, depending on if you're doing this class more as an honors class or a regular chemistry, high school chemistry class. Regular learns this. So, all right. So the first one, I have hydrogen plus oxygen making water, and I have 2 things becoming one thing. Now, before we talk about the 5 reaction types, we have to talk about something called the law. There's laws in science. They're not suggestions, they're the law, like gravity. And one of them is called the law of conservation of mass and energy. And what it says is that ever since creation, that matter, atoms, and energy cannot be created or destroyed. It only changes forms from one to another. So you can't make an atom. I can't make an atom. But I can change those atoms in these chemical equations from one to another. So it's interesting. It implies there was a point of creation. There had to be a beginning because we're here now. There must have been a start to this somewhere. And that ever since that point of creation, no more making stuff. No more making energy. No more making matter, atoms. They just change from one form to another. Now, the shocking part of this law, are you ready to be shocked, is what Einstein figured out. What is his famous equation? E equals mc squared. And what was so shocking about it is he figured out that matter and energy can be transferred from one to the other. And that's what's happening in nuclear bombs. The energy of the uranium or whatever's in that bomb, some of that matter actually gets transformed into energy by E equals mc squared. And that's why Einstein's so famous. Other stuff too, but that's the main one. All right, so this has to obey the law, not the suggestion of conservation of mass and energy, which simply put means what you put in is what you get out. So I put in 2 atoms of hydrogen and 2 of oxygen, but I got out 2 of hydrogen, but only 1 of oxygen. Where did the other one go? Well, it didn't go anywhere because it has to obey the law. So we have to do something called balancing the chemical equation. And it means that we add the numbers in front that tell you the amounts, just like my cookie recipe, and it makes it where it obeys the law. Okay? So how I do this is I just go back and forth, writing coefficients in the front, the numbers in front, the amount, until it all works out. So I have 2 atoms of hydrogen. I can draw them right here. We'll draw them as red balls. Okay? And I have, 2 atoms of oxygen. So it's diatomic, so I'm drawing them stuck on each other. Oxygen's bigger. Let's draw them bigger. It's more fun with sound effects. Okay, but water, I only have 1. So I draw the 1 big oxygen here. And I always say water looks like unimpressed Mickey Mouse. I don't get a sponsor from Disney either. And here are the 2 hydrogens. There's water, and he's unimpressed. He's unimpressed because he's slightly negative on that side, so that's his negative. Okay, so these work okay, but I have to have another oxygen over here, so I'm going to draw another Mickey Mouse, so that I've got enough oxygens over here, I'll have 2 of them. And of course he's unimpressed. So now my oxygens work out. I have 2 over here and 2 over here. But now I have 4 hydrogens over here. So I'm going to need another hydrogen molecule right there. Now my equation is balanced. And how I show that are with coefficients in front. I have 2 of these H2s and I have 2 of these waters. Now I have 2 times 2 is 4 hydrogens. 2 oxygens, and 2 times 2 is 4 hydrogens, and 2 times 1 is 2 oxygens. So these are the rules for balancing equations. You can only change the numbers in front. You can't change the little numbers underneath. If I had tried to do that and just put a 2 right there, I wouldn't have water anymore. I'd have hydrogen peroxide. And if you drink hydrogen peroxide and it's pure, you will die. Where water, you don't. So you're not allowed to change the chemicals. 30% hydrogen peroxide will bleach your hair. So imagine what 100% would do. All right, so that's how you balance the equations. You're also not allowed to insert a number in the middle of the formula. You can only change the numbers in front, coefficients. The numbers in the bottom, they're subscripts. It works like how the distributive property in math did. So like here I had that 2. It goes for the hydrogen and the oxygen. And if you remember in math, the distributive property, what's on the outside of the parentheses goes for everything inside. So if I had this math problem, 2 times 2x is 4x and 2 times 1 is 2. So remember that distributive property. If you don't remember it, go watch my algebra video, or pre-algebra. I do it in both of them. All right, so we just did our first balancing a chemical equation. Yay, go us. So let's balance, and we're going to talk about, I'm going to balance all of these, and as I do, I'm going to talk about what kind of reactions there are. There's 5 kinds. The first one is where 2 or more things become one thing. It's called synthesis, mainly synthesis. And so 2 or more things become one. And I always teach my kids to think of it like love, okay? So 2 things, you had lonely hydrogen and lonely oxygen, and they got together and made a couple water, and now they're all happy. Don't look at the subscripts, just look at the chemicals and see what's going on. So this is synthesis, it's love. Well, if people can get together and fall in love, what else can they do? That's right, they can break up. So in this one, I have 1 chemical that breaks up into 2. So this is called decomposition, and it's breaking up. It's heartbreak. I drew a little broken heart there. All right, so let's see if we can balance this. I have 1 lead here, 1 lead here, 2 oxygens, 3 oxygens. So there's a couple of ways you can do it. You can go back and forth because there's 1 plus 2. But it turns out if you can balance an equation with a fraction, you can do it, but then you have to double everything. Or if the fraction has a 2 in the denominator. Because you can't really split atoms, it makes a bomb, it's all messy. So, but if I, but I could sort of mess with this and make it, and straighten it out. I call it the amazing doubling rule. But we're not going to do it on this one. Hold on a second, I'm going to go back over here. All right. Anyway, so we're going to go back and forth. So I could put a 2 here, and now I would have 4, but now I have 2 leads over here, and I have 1 over here. So I go back over here. It's like, oh no, it keeps getting worse. Now I have 4 over here, 2 here, 2 there, and that actually did it. So look at it again. 2 leads, 2 leads. 2 times 2 is 4 oxygens. 2 times 1 is 2 oxygens plus 2 is 4. All right, so that, we didn't get to do our amazing doubling rule. Maybe one of these others I could show it to you. All right, so that's synthesis, decomposition. Now, what else can happen in love? The affair. It's scandalous. All right, here we have our happy couple, iron and oxygen, and along comes hydrogen. and hydrogen's been working out. He's buff, and he catches oxygen's eye. So the oxygen runs off with the hydrogen, and poor iron left all alone. This is called single replacement. Okay, and see how the iron was replaced by the hydrogen in its relationship with oxygen. And you'll read about all of these in your book, so be sure you do that. So let's see about balancing. 2 hydrogens, 2 hydrogen, 3 irons, 1 iron, but the oxygen is going to mess up. We've got 4 oxygens here and 1 here, so we need a 4. Now we've got 4 times 2 is 8 hydrogens. We need a 4 over here. 4 times 2 is 8. And we have 3 irons here. We only have 1 here, so we need a 3 there. This is, you just have to practice these to get better at them. Do them in pencil because you're going to have to erase. And you have to do it yourself because watching me do it and you do it is a whole different skill level. All right. So now this is called double replacement. And what this is first there was the affair. Sodium ran off with chloride and made salt. Sodium chloride. Oh, my salt's off here. Sodium chloride is NaCl. And then, so no good, lousy, two-timing dogs. Okay? So then the other 2 who were left over, the calcium and the carbonate, they got together. They went over to Starbucks and said, let's talk about how terrible they are. Yeah, they're awful. They're lying, cheating, no good. Low down elements here. And what happened? They fell in love. Love over lattes at the Starbucks. They're not a sponsor either, but they could send me some. They could send me some gift cards. All right. So and then they like when I was teaching this last week at school. One of the girls in my class said that happened, that her dad had an affair, and then her mom went to talk to the guy who got cheated on too. They fell in love, and he's her stepdad now. So she said, that happened in my family. So it happens, not just in chemical reactions. It's double replacement. It's the switcheroo. All right, so we can balance this one too, but you can just learn how to do these on your own. Look at the book, practice them, and there's some really good other videos out there that you can watch. There's a computer program called PHET, and they have a balancing equation simulator. You can Google it and find it. It's a game where you get to do it. And then there's also some more videos where teachers show you how to do it in more detail. There's one by a guy named Tyler DeWitt. He's got some good videos too that you can watch him, where he makes the camera right on his paper and he goes back and forth doing it. So if you need more help, look for those videos in that computer game. Okay, so those are our 4 main types, and here's our last one, and it's called combustion. It's burning. To burn stuff, you add oxygen. If it is a hydrocarbon made out of carbon and hydrogen, your products are carbon dioxide and water. You do combustion. You don't do it with a fire inside of you, but you have chemical combustion. You eat hydrocarbons like sugar, and then you breathe in all the free air in the room, and then you blow out carbon dioxide and feel your breath. It's moist. Water. You do complete combustion. Now, if there's complete combustion, is there incomplete? Yes, there is. With incomplete combustion, you have smoke and ash and carbon monoxide, which is a poisonous gas. It can kill you. So always be really careful about fire, not to breathe in carbon monoxide. Don't ever, or make sure any fire you have is vented. Don't put out so many candles that you're going to overcome yourself. Don't start your car in your garage and let it run. That will kill you. It produces carbon monoxide. So combustion. Now, so we were trying to think of a love analogy for combustion in my class, and we decided that we had heard that Italian people are supposed to be very passionate and great at love, that they love, and they don't do any of this decomposing or single replacement or double replacement, that they love well. And a girl in my class said, Miss Blackburn, I have a grandmother who is Italian, and she's been married 60 years to my grandfather, and they're still in love. So we were saying, okay, that's what it is then. This is the true love that lasts a long, long time. Combustion, the fiery love. So combustion is adding oxygen, and it can be complete or incomplete. All right, so if you want to come back and watch net ionic equations, doing this at a more honors level, go ahead. If not, this is good enough for learning about reactions. Like, share, subscribe. I'm Miss Lisa, and science is great.